All right, 5.5. This is pretty much going to be just a big review of everything we've done so far with exponents. So we'll dive in here. Multiplying powers. Remember, when we're multiplying powers, we are looking for base numbers that are going to multiply. So in this case, I have a -2, and there's no other base number for -2 to multiply with. So I'm going to write -2 in my answer. And then I'm looking here, and I want common bases, so x to the third and x to the third. We are adding the 3's. So we're doing 3 plus 3, which is going to give us x to the 6th. And then y to the 5th in this problem doesn't have a buddy, doesn't have a partner to combine with, so we just rewrite it as y raised to the 5th power. And remember, in order to get our powers, when we're typing them in, we use this A to the B button. So this creates the power in the in Delta Math, okay? Take another look here. We are working with 2 times 5. So base numbers just multiply. 2 times 5 gives us 10. We are doing x to the 4th times x to the 1st. Remember, if we don't see a number there, it's really a 1. So that's going to give us x to the 5th power. So that's what we got when we did those. And then again, y, forever alone, doesn't have a buddy, so he just gets rewritten, y to the 3rd. All right. So again, we're working with -15 times -11. Signs are the same, so we get a positive because we're multiplying. And 15 times 11 is going to give us 165. I'm working with now my x. X to the 3rd does not have another x buddy to combine with, so it just stays x to the 3rd. That's what I got in blue and red. Here we go. Okay, positive 165 for multiplying those. And then let's see, in green, I have y to the 5th and y to the 4th, which is going to give me, when we add 5 plus 4, we get 9, y to the 9th. Okay, raising powers to powers. So the first 3 were multiplying. The next rule here that we've worked on is raising powers by powers. So when we have a group being raised to the 2nd power, it means there are 2 sets of that. And what we've learned is that we are going to take each individual piece. So -5, x to the 4th, and y. So again, that's -5. I'm putting that in parentheses because the negative's attached to the 5. X to the 4th, y to the 1st. I'll put a 1. And all 3 of those, clean that up, all 3 of those are going to get a power of 2. So 5, 4, or -5, x, and y are all getting raised to the power of 2. And so we're going to do -5 to the 2nd power, which means -5 times -5, which is positive 25. X to the 4th raised to the 2nd power, we multiply, so 4 times 2 is 8, and 1 times 2 is 2. Okay, so again, each individual piece, each base, and whatever exponent is attached with it in the parentheses is going to get raised by the power that's on the outside. So I have 6 is going to get raised by a 2, x to the 5th gets raised by a 2, y to the 3rd gets raised by a 2. 6 to the 2nd power is 6 times 6, which is 36. X to the 5 times 2, well, 5 times 2 is 10, so that's x to the 10th. And y to the 3rd times 2 is y to the 6th. So raising a power by a power. Here we have this whole thing raised to the third power. So again, I'm going to have a negative 3 in parentheses, and x squared, and a y to the second power. And all of those are getting a power of 3. So negative 3 is going to be raised to the third power. X to the second is getting raised to the third power. Y to the second gets raised to the third power. So this means 3 sets of negative 3. So negative 3 times itself 3 times. I'll expand it out so you can see it. In delta math, you can just use the calculator, and you can do parenthesis negative 3 parenthesis raised to the third power. So in delta, you can do it in the calculator. This is what it means. Negative 3 times negative 3 is positive 9 times negative 3, which is negative 27. X to the second raised to the third. 2 times 3 is 6, so I get x to the 6th. And y to the second raised to the third is going to give us y to the 6th. Okay, now we're going to look at dividing. Remember, when we're dividing, we're going to reduce our base numbers. So I have 20 and 4 can both be reduced by 5. So if I do 20 divided by 5, it's going to give me 4. Oh, I'm sorry. I was thinking about the answer. They can both be reduced by 4. 5 doesn't go into 4. 4 goes into 4. 4 goes into 4 one time. 4 goes into 20 5 times. That's where I was thinking about the answer. Okay. So 20 reduced down to a 5, 4 reduced down to a 1. Here we have x to the 5th over x to the 1st. And when we divide, we subtract. So 5 minus 1 is 4, and we're going to write that on top. And then this is y to the 1st. I can't seem to make a 1. Okay, y to the 1st. And we have 8 and 1. So 8 minus 1 is 7. And then we're going to be y to the 7th on the bottom. So our final answer here would be 5x raised to the 4th power. You'd hit that AB button. Divided by 1y raised to the 7th power. And again, this is all review. I just want to put it all in one place. So for this one, we have 25. A base of 25 doesn't have anything to reduce with. So it's just going to stay 25. For my x's, I have x to the 7th and x to the 8th. So I'm going to do 8 minus 7, which is 1. And I write that in the denominator because there were 8 down there and there were 7 on top. So there was 1 more down on the bottom. And then same thing for our y's. We're working with 8 on top, 3 on the bottom. So we subtract 8 minus 3 is 5. And there are 5 remaining on top. So for our answer, you would hit 25y raised to the 5th power divided by x. All right. 8 doesn't have anything to reduce with, so it stays 8. For our x's, we have 7 and 5, so 7 minus 5 is 2, and that gets rewritten down below. And for our y's, we have 7 and 2, and 7 minus 2 is 5, and that also gets written down below because there were more down there. So y to the 5th. So we would hit 8, we would hit divided by to make over. X, a to the b button gives us a 2. Y, a to the b button gives us a 5. Okay. Now let's look at negative exponents. So a negative exponent means that it's in the wrong place. It's unhappy. And so if this is all sitting over 1, the 4, remember, is its own thing, and that's just fine where it's at. He doesn't need to move. He's being good. Okay, but this x raised to the negative 3rd power is unhappy in the numerator and needs to move down into the denominator to become positive. So now we have 4 over x raised to the third power. So again, this -3 is happy where he's at. Even though it's a -3, it doesn't have a negative exponent. It's just a -3. So -3 gets to stay where he is. He's happy. He's fine. X to the -2 is unhappy and needs to move downstairs to become positive. So we get the answer -3 over x raised to the second power. All right, we have 5 is just fine where he's at. Does not need to move. However, x to the -2 is unhappy and needs to go downstairs. So 5 stays upstairs. X to the +2 now because we moved him downstairs and now he's happy. Okay, last couple things. This is a little bit new, but you'll get the concept. This means the whole group is in the wrong place. So this is sitting over 1. So when you see parentheses, that means this whole group is unhappy, and we can actually just move the whole group downstairs. So it's -4x to the +1 now. If we don't have anything to write, we can write a placeholder. And then we can work out that first power. So everybody on the inside, -4 gets a first power, x gets a first power. Or that's what they already have. So that's -4 to the first and x to the first. And then in red here, they're getting another power of 1 that will multiply. So 1 over, it still is just -4 and x. So if you get a negative power and it's just it's changing the whole group, it means it's in the wrong place. So all of this is unhappy being on top. So we're going to move it downstairs to give it a positive. And then we do what we did earlier, where each piece gets a 2. So 5 gets a second power and x gets a second power. And then we just work out 5 to the second power is 25. So this would be our answer. You won't see too many of those, but they do come across, okay?